This is the new application assignment for the statistics homework. When starting the application, the first thing to do is select a random variable. For now, there is only one option, which is the one required by this week's assignment. But in the future, if we'll develop other simulations which require different kinds of random variables, then I will add them to the list so they can be selected as well. For now, let's select Bernoulli, press OK, and we can see this new form in which our simulation will be displayed. On the left, we have several options: the number of paths, the number of samples, the probability of success for the Bernoulli random variables, and the point in which we want the histogram. Then we have the interval size, which will be used to draw the histogram and the grid behind the simulation drawing. And we have also a combo box, which allows us to select between 4 different simulations. If we don't select anything, the default one will be the sample mean, as we can see here. Taking a look at these simulations, we can see that the sample mean is basically the relative frequency of success for the Bernoulli random variable, and this is converging to the expected value, which is the probability of success 0.5. If we change it, then this will also change. Before taking a look to the other simulation, let's see these other options. We have one to hide the tags on the y-axis. This is because when we decrease the interval size, there may be a lot of tags here, and so we can have a nicer looking drawing in this way. And then we have a lock drawing, because this is an interactive rectangle, so we can move it, we can change the size, and if we press lock drawing, then we can no longer do anything. Now let's take a look at the other different simulation, and for this we will also look at the code, so we have a better understanding of what are we doing. The simulations are generated by this function run simulation, and the default case here is this for the sample mean, which is the relative frequency of success, and we can simply say that we take the sum of all the successes of a random variable on one path, of Bernoulli random variables on one path, and we divide it by the time t, the sample number t. Then we have the other option, which is the sum. For this one, we are only taking the sum, so we need to increase the sample the interval sizes, because we will result in much bigger number. And if we press generate, we can see that the behavior is quite different. Instead of converging to a single value, here these paths are diverging, and we can see that they are spreading over a bigger and bigger range as the simulation goes on. Then we have the standardized sample mean. Here, in this case, we are computing the sample mean as before, but then we are dividing it, we are subtracting the expected value and dividing it for the standard deviation, so that if we adjust here an interval size, because it will be smaller, we can see that it's not diverging nor converging to a single value, but instead is converging in distribution to a normal distribution centered on 0 and with variance 1. And we can see here in the histograms that we have this bell shape. If we repeat the experiment many times, we can see there is always this bell shape. Then we have also the normalized sum, in which we are dividing the sum by the square root of the sample number. And here we will have a similar behavior. The sum is not longer diverging, but instead is normalized to have a constant variance of 1. And so we can see that it will keep the normal distribution shape. Now let's take a closer look at the code. We have already seen how the simulation are done. Here in this form Bernoulli.cs there aren't any other particularly interesting parts aside for the event handler, which handles when the button generate is pushed, and we are simply try to run the simulation. If anything goes wrong, then an error message will be displayed, and then we are retrieving the data from the form, generating the distribution for the histograms and the other drawings, and then creating those drawings and drawing them. The real heart of this application is this class Bernoulli, which allows to sample Bernoulli random variables, and we have two constructors. One only takes the decimal number representing the probability of success of the Bernoulli random variable, and the other also takes a random generator, which we are using it for generating the Bernoulli random variable and with the inversion method here we can see that we have this next sample, and it's called like that because it's parallel to next double or next of the random generator, and we turn the uniform next double to a Bernoulli by using this simple function. And why are we have this constructor in which we can pass the random generator is that maybe we don't want the generation to be completely random, especially in debug. For example, we can pass the generator with a seed so that we know which random numbers will be generated. And so I kept this as an option. Then we have all the drawings. Those are resizable drawings that are modular. So these lines and histograms is the thing that is actually being displayed, and is composed by two histograms and a many lines chart, which is on its own composed by a grid and a collection of lines. And so we have classes for the lines, the histogram and the grid, and then we also have the class interval, which is used by the histogram, and the only variation here from the previous homework is that instead of double in the interval we are using decimal, because dealing with small numbers such as the relative frequencies of success, we required more precision on the decimal positions of the numbers, and double is not appropriate to be very precise on the decimal numbers, so we better use decimal.